operation we call boiling in a syringe. It's another one of those that's put away in a drawer and you can quickly grab and use when you're talking about boiling and boiling points. And most of us know that under normal atmospheric conditions, the boiling point of water is 100 degrees Celsius at 1 atmosphere. And a lot of people think if it's boiling, it's 100 degrees. Well, over here I have some water that's been heated a little bit. And actually there's a nice thermometer here, so I'm going to look at the thermometer and see what it's telling me right now. It's cooled off some from where it was, but right now it's reading about 82 degrees Celsius. So we're going to take a syringe, and we have a little valve on the bottom of this, and we're going to pull in some liquid. Whoop, I want the 82 degree liquid. There we go. Pull in some liquid. Now, one of the vital things is to try to get rid of the air bubble at the top. So I'm going to try and just get rid of a little bit of air. There, I'm going to close it. And now we're going to reduce the pressure on the water. Remember, it's 82 degrees. So here we go. And it's boiling very, very well. Notice something else, though. It boiled very rapidly to start with. And now it's slowing down quite a bit. Now that's a little more chemistry. Because in order to make something boil, we normally end up having to heat it. Boiling is an endothermic reaction. You have to put heat into water to make it boil. So now here we weren't putting any heat into the water, so the heat must have been coming from the water itself. So the water is cooling down. And the more it cools, the harder it is to make it boil. Now let's try this at a little bit colder temperatures. I brought another jar in. This was simply taken out of the hot water tap a little while ago. And it's reading 47 degrees Celsius. So that's quite a bit colder. And so we're going to pull a little bit of water in there. And again, get rid of the little excess, like that. Now, from the previous experiment, we should expect something a little different. If I can make it boil, it should boil, but what should happen very quickly? It should slow down and it should stop relatively quickly. So here we go. We're ready? We're going to try it again. There it is. It's boiling, but now it's starting to slow down already. It was boiling at 48 degrees Celsius. Now, I wonder what would happen if we went colder yet. Now, this was not that easy at 48, so it's going to be harder and harder. It is possible to actually put water in a vacuum pump, and it has a pretty good what we call vapor pressure, so it's always evaporating some, so it's hard to get the pressure really low on it. But physics teachers sometimes take water in a vacuum pump, a thin layer, and they take a little beaker with sulfuric acid in it that pulls moisture out of the air rapidly, and they end up creating a vacuum, and the water actually freezes. You can freeze water by reducing the pressure on it. That's really kind of neat. Now, I don't recommend you doing that because the sulfuric acid in the vacuum pump tends to end up getting into the line and the oil of the vacuum pump,